Now, we are going to look at another application of differentiation. This one requires us to, first of all, establish the intercepts. Where does the curve cut the x and y axes? We establish the stationary points. These stationary points, we need to establish the nature. That was in our previous video, the nature of the stationary points. Then we just have to press sketch. Not so complicated. So this is our curve. We have sketched the curve this, meaning that we have to, by default, establish the turning points. Then we distinguish between these turning points. Is it a maximum, minimum? Is it a point of inflection? So here we start by writing our equation, which is y is equal to x power 4 plus 2x cubed. And getting the intercepts, we can say, we can start with the x-intercept. At the x-intercept or at the x-axis, y is equal to 0. If y is equal to 0, this means that wherever there is y, we are going to put there 0, and we shall have 0 is equal to x power 4 plus 2x cubed. I factorize out the highest term, the common factor, which is x power 3. Then I stay with x plus 2. So either x is equal to 0, a curve is going to cut at x is equal to 0. Then also x, if I equate this bracket to 0, the curve will also meet the x-axis at x is equal to negative 2. This is for the x-intercept. Then I proceed and get the y-intercept. Y-intercept. Then at y-intercept, we say that x is equal to 0. The y-axis x is equal to 0. So wherever there is x, we are putting there 0 in the equation. So 0, 0, it becomes 0. So y is 0, and the coordinate there becomes, let me first write the coordinate. For this one here, we have 0 and 0, for y is equal to 0. Then we also have negative 2 and 0. Then for the y-intercept, we are saying that x is equal to 0, meaning that our value of y is also going to be 0, because we have already seen the coordinate here. So still the coordinate is 0, 0. Then we are going to establish the stationary point. Is it a turning point or point of inflection? So we state the stationary point. For the stationary point, we differentiate, of course, divide x. When if you divide x, our function is this. It will give us 4x cubed plus 6x squared. But we know very well that at stationary points, the gradient function is 0. So we shall say 0 is equal to 4 this plus 6x squared. Then we can factorize out the common term. So the common term we have is 2x squared. Here I will stay with the 2x plus here I will stay with the 3. Now I'm going to equate this to 0 and also this to 0. So the turning points I get x is equal to 0 as the x coordinate. Then if x is equal to 0, the value of y is automatically y is equal to 0. So this is the turning point. We are here to establish the nature. Then I also equate this to 0, which x value will be a negative 3 over 2. Negative 3 over 2. And the y value now becomes, we get this value and substitute it in here. Let me press this in a calculator. As you get negative 3, press this and put in negative 3 over 2. You get the value of y. The value of y becomes, this is our y value will become, we are substituting in the y, because we want to get the value of y.
Negative 27 over 16.
So we have negative 27 over 16. And now the coordinate is, let us write it in points such that we know where to locate it. This is the negative 1.5. Then this one is going to be
Negative 1.6.
negative 1.6.
1.7.
Okay, 1.7. We shall plot it around there. Now, we have to establish the nature. We have established the turning points, but what is the nature of these turning points? So we come and get the nature of the stationary points. The nature of the stationary points. And here we can use the table. We said that here we put the value of x, then here we put the sign of the y x. Our value of x, we go to the left of the first value of x. In this case, we start with the smallest, which is a negative 1.5. Then we go to the right of that same value. We draw those two lines, we get to the left of the next x value, which is a 0. Then we go ahead and find the value that is on the right. Then we substitute in. We get a value that is on the left of negative 1.5. It can be negative 2. But then we are substituting in the formula of the y x, this one here. When we put in negative 2, which value shall we have?
Negative.
This is a negative. Then this is a 0. We say the negative is like this. This is represented like this. Then if you put in a value that is on the right of negative 1, but doesn't exceed the 0, you can use a negative 1 itself. You can use a negative 1 itself. Which value is that? It gives us a positive by default. That's a positive value. So we are having this in this form, which gives us a minimum. So this is the minimum turning point. This one here, a minimum. Then we have a point here. We go to the left of 0 and we choose a value. Left of 0, which value is that? Left of 0. We can use this. It is automatically going to remain, which is positive. This is a 0. Then we choose a value on the right. I'm seeing a positive. This is a positive. So we have something like that. So this is the point of inflection when you are plotting. So this is the point of inflection, but it is coming from the positive. It remains straight, then it continues to the positive. Now, after establishing the stationary points, the nature, and have the sketch. We can have our sketch. Our intercepts, we have 0, 0, which is here. But this is also a turning point. We are seeing it as a turning point, and it is point of inflection. So they are telling us that the curve will come like that. Then it remains, it changes course like that. That is what it will do. Let me repeat it. Our curve is going to come. It will come from the negative like that. It remains like that, then it proceeds. That's what we call the point of inflection. So you can leave it at that. Then we look out for other intercepts. We have a negative 2, 0. Negative 2, 0 is somewhere here. We can have it plotted there. So I've catered for all of this. This is repeated. So the curve meets the axes here and here. Then we have to look for another turning point, which is negative 1.5 and negative 1.7. Negative 1.5 in the x, it doesn't reach a negative 2, so it is just almost half. Not halfway, but almost closer to negative 2. Then negative 1.7 is in the y direction, which is somewhere here, like this. And they are telling us that it's a minimum turning point. So I also got where it is. I put something like that. This is negative 1.5. Then I have a negative 1.7. There is a point of inflection. So if I'm to complete my curve for the one I'm sketching, I will have to bring this, join it to that. It forms a minimum there. Then it goes and it intersects with that. Then I can extrapolate it like that. So this is my y-axis. This is my x-axis. This is the point of inflection. You can see it. The curve comes, it changes course, and it continues that direction. So we have to label our curve at the end, and we are saying this is y is equal to x to the power 4 plus 2x cubed. That is what we shall have. There are some instances whereby the point of inflection at 0, 0 comes from the left, it goes to the, for example, it comes like this from the left, it stays constant, then it continues like that. So it means that that curve will come like this, does that, then does that. There is that possibility also. But for our case, this is not a possibility. The actual thing is what we have there. This. And that is our work there.